Trig equations of quadratic type. So take a moment to read over all this blueprint here. This is strategies at solving the trig equations. And then unpause it when you're done reading it and writing it down. And let's go to the example one. So example one says solve the equation on the interval of 0 to 2 pi. So we are talking about radians here. So let's solve for it. We need the sign by itself. So I'm going to add this negative 3/4 to both sides. So it gives me sine squared of x is equal to 3/4. All right, so now I need sine x, not sine squared of x. So I'm going to take the square root of both sides. And since it's an even root, that means I get a plus or minus. So now I have sine x is equal to plus or minus. I'm going to break it up where I separate each part under the root. Now I have plus or minus square root of 3/2 because square root of 4 is 2. So whenever you go to the unit circle, and you're going to remember the order pair is cosine, comma, sine, we're going to go to the unit circle and find where all the sine values are square root of 3/2. And we got plus or minus, so we're going to find one in every quadrant. So that means my answers are going to be pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Okay, now let's do example 2. Example 2 says solve the following equation on the interval of 0 to 2 pi. So let's add that negative half to both sides. So now I have sine squared x is equal to 1/2. Let's take the square root of both sides. So we get a plus or minus because it's the even root. So now what do I have? I have sine x because the square undid the square root. Plus or minus square root of 1 over square root of 2. Well, square root of 1 is just plus or minus 1 over square root of 2. However, we cannot have a square root in the denominator, so I'm going to multiply by its conjugate, which is the square root of 2. So now I have 1 times that square root of 2, which is square root of 2 over square root of 2 times square root of 2 is 2. Because remember, the roots, it's the same as writing it as 2 times 2 inside there, which is square root of 4, and so on. So now I have sine x is equal to plus or minus square root of 2/2. And we're going to go to the unit circle. And since we have a plus or minus, we know we're looking at all 4 quadrants. And we're going to list everywhere sine is the square root of 2/2. It gives me pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Okay. Let's go to our next example. Find all real numbers in the interval of 0 to 2 pi that satisfy the equation. Use the radian measures. All right. Well, we're going to use some substitution here because we have, or we can factor. Sometimes we need to use the substitution. But before we do that, I noticed that I have a sine square and a sine here. I need them both on the same side. I can't put them together, though. However, I can rewrite them. And then since we have a square, we know we have a quadratic, right? The square being the highest degree. So since it's a positive sine x on this side, I'm going to subtract it from both sides. Now, let's rewrite it. I got 7 sine squared x minus sine x equals 0. And now we can use substitution. You can use a u, you can use a y, you can use whatever you want to substitute in. And I want to let y equal sine of x. And the reason why I want to let y is because the order pair, we got cosine, sine, and we know that sine falls in the y coordinate. So that gives me 7 times y squared minus y is equal to 0. I'm going to factor out a y from both of these. So now it leaves me with 7 y1 minus 1. And it's basically saying since I'm factoring a y out, I'm dividing each one by y. So that's how I got my answer. Now I'm going to set the y equal to 0 and the 7y minus 1 equals 0. I'm going to go ahead and solve for this. Get it equal to y. Okay. So now that I solved for it, I added the -1 to both sides. I divided by the 7. So now I have y equals 0 and y equals 1/7. So now let's put in its place of y, which is sine of x, right? Is equal to 0. Let's find its inverse. So we get x is equal to sine inverse of 0, which is 0. Let's come over here and do sine of x equals 1/7. Let's say, okay, x equals sine inverse of 1/7. And remember, we're in radians, okay? So now let's plug it in. We have sine inverse 1/7. Let's see, what is 1 divided by 7? Okay, hang on just 1 second. Let's plug it in. Oh, make sure you're in radians. I was going to say my numbers are just not, they just don't look right. Make sure I'm in radians. Sine inverse 1 divided by 7. There we go. That looks much better. I'm going to round to the nearest tenths. So I get 0.1. So I know that I have a 0, and they may use a decimal in the assignment. Just make sure and read. A 0 would be fine with me, but make sure and look at what it wants to, how it wants you to answer it. So we have those two values for sure. It's a quadratic. You should have 2 up to 4 values, but you can have 2. Okay. Example 4. It says find all the values of theta in the interval of 0 to 360 degrees that satisfy the equation using the degree measures. So we're going to have a little bit of work to do here. I'm going to notice that I have a quadratic because the highest is a square. The highest degree is a square, right? And I can write this in factored form. If you have in trouble with factoring, you can use the AC method or trial and error. Trial and error is a lot of work, but holler at me. I'll be happy to share a video with you, or I'll be happy to go over the basics on factoring. However, I noticed that 49 is a perfect square and 25 is a perfect square, so let's look at that. What if I said 7 leads each parentheses, 5 ends each parentheses? Well, we got to put the sign of theta on the 7s. And the sign on C tells me if you add or subtract. And since it's a plus, I know I'm going to add. Okay? The sign on B tells us the sign we're using. So since we're adding and the sign on B is positive, we're going to use a positive. If the sign on B was negative, we'd have negative in both these parentheses. Now, I just want to double check to make sure that I did a good choice. So if I factor it back out, I'm going to come over here and check my work. If I factor it back out, I'm going to say 7 times 7. I'm going to put a plus, and you can put the sign there if you want, but you don't have to. And then I'm okay. So I said 7 times 7. Now let's say 7 times that 5 plus 5 times that 7 plus 5 times 5. And all I'm doing is just checking, guys. So 7 times 7 is 49, and we know it goes with sine squared. So we're not going to focus on the first one. The 5 times 5 is 25. We're not going to focus on it. What we're focusing on is the middle, because remember, it's got to add up. Because the sign on C says we're adding and to get whatever B is. So we got positive 7 times 5, which is 35, and a positive 5 times 7 is 35. You add them together, it gives me positive 70. Check. So I factored it good. Now I'm going to take these parentheses, 7 sine theta plus 5. Since they're identical and there's 2 of them, I can write them to the power of 2, set it equal to 0. And now I can focus on what's inside here. But don't forget that we have 2 of these, right? Okay. Okay, so now let's take that 7 sine theta plus 5, set it equals 0. I'm just solving for this right here right now. So I got 7 sine theta is equal to negative 5 divided by 7. Now I have sine theta of negative 5/7. And now I'm going to take the inverse of sine. Okay. And make sure, because it wants it in degrees, so we're going to flip it back to degrees mode. And I'm going to say sine, or we're doing the inverse. Inverse sine negative 5/7. And I'm going to round to the nearest, I'm going to go out 4 decimal places to the nearest 10,000. Negative 45, 5847. I believe one time I went out to the nearest 5 decimal places and I called it 10,000. I apologize. It wasn't 10,000 on my notation, so I apologize. 4 places out is 10,000. Now in the homework assignments, it will probably just tell you 4 decimal places. But while we're still working on the answers, I would not round. I would go out as far as I can until you get to the end and round, because when you round your final answer, it may be off by a little bit if you round too soon. All right, so now we want, oh, I don't know what happened to everything we just did, so you may want to rewind. My apologies. I'm not sure what happened. So what I'm going to do is I'm going to go back to this part here. And just rewrite this right quick. So now we got the inverse of sine. It's approximately a negative 45.5847 degrees. Okay. Now we're caught up, and I apologize. I'm not sure why it's messing up so much. But anyways, now we're wanting to stay within the 0 to 360 degrees. So what I want to do is take that 180 degrees. So again, if you wanted to draw this out, you got 0, 180, 360. We already know we got a negative 45.5847. That means this circle is going clockwise, right? So I'm going to take that. I'm going to say subtract it, which what happens at negative times negative becomes a positive. So we're going to end up adding it. So we got 180 plus that 45.5847. So I get, and round this one to the nearest tenths, I get 225.6 degrees. That's one of my answers. Okay, so it makes sense because we're going clockwise with this one. Now what I want to do is take that 360 degrees. I'm going to add that negative, right? Let's add it, which means we're going to end up subtracting. That makes sense too. So 360 minus that 45.5847. Now I get 314.4 degrees. And that's my other answer. So let's give the computer a second. Okay, let's go to our next example. It says find all real numbers in the interval of 0 to 2 pi that satisfies the following equation. So we have cosine x plus cosine negative x. Well, what do we know about cosine? We know cosine is even. So that negative will go away. If this was sine, that means the negative would have came out front because sine is odd. So knowing that, I'm just going to rewrite it one more step just because cosine's even. We know that it's going to stay positive. Then I'm going to add these two together. So I have 2 cosine of x is equal to square root of 3. Now I could divide by the 2. So now I have cosine of x is equal to square root of 3 halves. We can still follow the rule that a is not equal to 1. It's not greater than 1. It's not negative 1. It's not 0. So we look at is s greater than or less than 0. So when we do that, we take the inverse of cosine. And what do we get? We take cosine. And we are working in radians, so change your calculator back to radians. So I got inverse of cosine for 3 halves. So it gives me pi 6. Since it's a positive, we know that it's greater than 0. So then that means we're going to use the formula of the set of x that builds when x is equal to s plus 2k pi, or when x is equal to 2 pi minus s plus 2k pi. Okay. Oh, I don't know why it keeps doing that, guys. So here, I'm going to rewrite it back. Just the answer. You might have to rewind it. Okay, so let's take this side and let's solve for this first one. So I'm going to plug it in. It gives me pi 6 plus 2k pi. I'm going to say, okay, when k is 0, I get x is equal to pi 6. Okay. If it asks us for more than 2 values, then plug in 1 for k and so on. This next side, we're going to say 2 pi minus that pi 6 plus 2k pi. We got to have a common denominator. So now I have 12 pi minus pi divided by 6. So now 11 pi 6 plus 2k pi. So x is equal to 11 pi 6 plus 2k pi. Plug in 0 for k. And we get x is equal to 11 pi 6. So we have values of pi 6 and 11 pi 6. Okay. I'm not sure what's going on my computer. Sorry about that, guys. Definitely going to IT. All right. Example 6, find all real numbers in the interval of 0 to pi that satisfies the following equation. So I'm going to go ahead and use substitution because look, I know, well, another thing is, let's go ahead and add this one to both sides first. We know we have a degree of a square. The leading degree is a square, so we know we have a quadratic. All right, so now what I would do is substitute y again for sine of x. So now I have 2y squared minus 3y plus 1 is equal to 0. Now, the product of 2 times 1, that adds to give me -3. You can do it that way, or you can use the quadratic formula, which is -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. You can use that method if you would like. As long as it's written in descending order, it will work out. However, I do know that 2y is going to leave one parentheses and y will leave the other one because the products of 2 is 1 times 2. I know that I got a product of 2 times 1 that adds, because the C tells me we add to get a -3. So both signs are going to be negative because we're adding. We have, let's look a little further. And the product of 2 is 1 times 2. That adds to give me 3. So I'm going to put 1 and 2 here. Now, let's work on this. Okay? This may not work. This is why we're going to use the quadratic formula to double check. So I have 2 times that gives me my 2y squared. 2 times this is 4. That did not work. So what if I put the 2 here, mark this out, and put the 1 here? Now I have 2 times that y, and this 2 times that 1. So now I have 2 minus 2, no, or plus 2. It's still going to give me 4. So this method does not work. So I'm going to use this quadratic formula. And my b, remember quadratic is written ax squared plus or minus by plus or minus c. So my b is -3 plus or minus. I'm going to put that -3 in parentheses because I'm going to square it inside this root. I got 4 times a, which is 2, times c, which is 1, all divided by 2 times a, which is 2. So negative times negative is a +3. -3 squared is 9. -4 times +2 times 1 is a -8, all over 2 times 2, which is 4. So now I have 3 plus or minus 9 minus 8 is 1 over 4. So now I have 2 solutions. I have x is equal to 3 plus 1 divided by 4, which gives me 4 over 4, which is equal to 1. And then I have x equals to 3 minus 1 over 4, which is 2 over 4, which is 1/2. All right. We're doing pretty good. So now what I'm going to do is put it back into place. So I know I wrote x here. I should have used y. I should have made this as y because we said y is our substituted here. So now I have x is equal to 1, which is actually y equals to 1. So plug in sine of x equals 1. Take the inverse. Sine inverse of 1. Let's find it right quick. The inverse of sine 1 is pi halves. Oh, that makes sense because sine is 1 at 90 degrees. Yeah, that makes sense. And then I'm going to say y is equal to that half, and then I'm going to plug it in sine of x of a half. Take the inverse. So when I plug it in, let's do the sine inverse of a half. Get pi 6. Okay, hopefully I'm going to scroll down. I'm hoping that I'm not going to lose everything. Let's see. Let's make sure. All right. Yay. So I got 2 values here, pi halves and pi 6.